everyone. Today I'd like to talk to you about mutations in nucleic acid and what kind of structural differences that will cause in the products of genetic transcription and translation. We'll start with this wild-type normal sequence of double-stranded DNA. After it goes through transcription, it becomes mRNA, and then it will be translated into an amino acid sequence with the amino acids methionine, valine, serine, and lysine. In our first mutation, the mutated sequence has a point mutation at this position. Where the original sequence had a T, it now has an A, making it a transversion. The A persists into the mRNA sequence after transcription, and the new amino acid sequence is methionine, valine, arginine instead of serine from the original sequence, and lysine. Because only a single amino acid changed from the original sequence in the mutated sequence, this is known as a missense mutation. In our next mutation, in the mutated sequence, we have a point mutation at this position, from an A in the original sequence to a T in the new mutated sequence, making this a transversion. After transcription, we have a U in this position, which prematurely terminates the sequence. So the new amino acid sequence is methionine, valine, serine, and it lacks the lysine that the original sequence had. This makes it a nonsense mutation, which is classified by the premature termination of the amino acid sequence. In our third mutation, we have a point mutation at this position where we have a T instead of a C from the original sequence. This makes us a transition. After transcription, we have a U at this position in the mRNA sequence, and the translated amino acid sequence is now methionine, valine, serine, and lysine, the exact same as the original sequence, making this a silent mutation. In our fourth and final mutation, we have a point mutation at this position, a C from an A in the original sequence, making this a transversion. And in the mRNA sequence, we have a C at this position. And in the amino acid sequence, we have methionine, valine, serine, lysine, tyrosine, serine, threonine, and so on. This is because the C at the mRNA sequence actually no longer encodes for a stop codon and continues to read through, making this a read-through mutation.